Many students know the equations here, but still don't know where to start. This problem can be solved in 5 steps. 2 strings, 1 object. The weight is 100 newtons. What are tensions in the strings A and B? The object is at rest. That simply means, in Newton's equation, acceleration equals to 0. So this is a force balance problem. The net force must be 0. Once that is clear, these 5 steps give you a clear path. Let's take a quick look at the 5 steps. Choose the object. Draw the forces. Choose axes and resolve forces. Write equations. And solve them. This is not just for this problem. Force balance, equations of motion, even rigid body problems, which you may study later, the order is always the same. Now let's go through them one by one. Step 1, choose the object. Newton's equation is always about one object, not the whole system, not the strings. Here we want the tensions in the strings. So we focus on the ball. That's it. Step 2, draw the forces. We draw only the forces acting on the chosen object. A safe way to think about forces is to group them into 2 types: non-contact forces and contact forces. Let's start with non-contact forces. Gravity, which is 100 newtons downward. Now for contact forces. If something is touching the object, assume it exerts a force. So what is touching the ball? The 2 strings. Tension A, from here pulling along this string. Tension B, pulling along the other. So on the ball, we have exactly 3 forces. For now, the arrows just show directions, not worrying about their sizes yet. Now step 3, set axes and resolve forces. To express that condition mathematically in equations, we choose coordinate axes. Usually, we set horizontal and vertical. Once the axes are set, we decompose each force vector according to the coordinate axes. This force resolves along the axis, and this one as well. It is important to be clear about what this means. After decomposition, the components are not new forces. They have exactly the same effect on the object's motion as the original vector. Nothing physical has changed. The force only looks different because we are now viewing it through the lens of our coordinate system. But remember, a coordinate system is a lens. You are free to choose the directions that make the problem easiest to describe. For example, we can choose axes along the strings, and force resolves like this. Now, step 4, write equations. Because the object is at rest, the acceleration is 0. So in Newton's equation, the net force must be 0. So in each direction, the sum of forces must be 0, vertically and horizontally. The directions are defined by our axes. Force directions become signs. Positive direction, positive sign. Negative direction, negative sign. The physics does not change, only our description does. Step 5, solve them. At this point, the physics is already done. We are just solving 2 equations for 2 unknowns, tension A and tension B. This part is mathematics. Important, but not the hard part. Even if the sketch isn't accurate when you draw forces, the equations give the correct magnitudes. Now let's step back for a moment. What did we actually do? We didn't use a special trick. We didn't memorize a formula. We were just reading Newton's equation carefully. And reading it carefully means this: Newton's equation can describe only one object at a time. So first, we had to choose which object to focus on. Then, we looked only at the forces acting on that object. Finally, we wrote Newton's equation for that object and solved it. That's all we did. In this problem, the object was at rest, so the acceleration was 0. That's not a limitation, just a special case. When the acceleration is not 0, we follow the same steps. The equation does not change. Only the acceleration does. That's why this way of solving problems keeps appearing. It works for force balance. It works for equations of motion. And it will work again when we move on to rigid body motion in the future. Different problems, different situations, but the order is always the same. Thank you very much for watching this video. If you want to look at the ideas one by one, I've made shorts that focus on individual concepts. This video brings those ideas together. You can find the related shorts in the playlist. I'll see you next time.